Assalamualaikum and greeting to my panel Encik Afiq Amiruddin and Encik Ahmad Nizam. This is my video presentation for PSM1 on development of surface pattern on mic steel with parameters manipulation of laser engraving process for part refurbishment. My name is Muhammad Hafiz bin Muhammad Rosli. I am in my third years of study towards Bachelor of Mechanical Engineering Technology in Maintenance Technology with honors. My supervisor is Professor Madya Engineer Dr. Muhammad Hazli bin Abu Bakar. For Chapter 1 Introduction, I would like to explain more about laser engraving. Laser engraving is a subtractive manufacturing process that involves changing the surface of an object with a laser beam. The laser is used to mark the surface of a metal workpiece. This method is mostly used to create images that are displayed at eye level on the material. The laser produces a lot of heat, which causes the substance to spray and show the holes that make up the final image. Laser marking has various advantages over traditional marking methods, including the fact that it does not require tool wear due to its high level of automation, as well as free programming and character selection. The working concept of laser engraving is based on vaporization, which occurs when a laser system interacts with a material through a focusing lens, and causes the vaporization and melting of the materials employed in the work. Next, the laser engraving is used to engrave a specific image or trademark onto a chosen material. Before the engraving process can begin, a file from a computer must be transferred to the machine controller, which then sets the laser. When the process begins, the beam generates a large amount of heat, which burns or evaporates the surface in accordance with the image in the file. There are two types of engraving, which is surface engraving and line engraving. The first type vaporizes the material to embed an image or give the design a three-dimensional appearance, while the second employs vector image to follow routes or lines. Here are some of the examples of the laser engraving machine. The left one is the fiber laser engraving machine, and the right one is the CO2 laser engraving machine. The quality of the engraved surfaces is the most important component in practical laser engraving applications. Some of the problem statements that could be faced during the process of laser engraving are the abrasive surface of mild steel. Most of the material uses in engraving process are in not too bad condition as of the roughness surface. So, by engraving the material such as mild steel, the abrasive surface can be removed and produce a new surface with less roughness. The second one is material characteristic. Metal material characteristics should be measured to reduce the consumption of metal materials during the engraving process due to overburn. The third one is about the various parameters used. During engraving, various parameters such as power, speed, frequency, and loop count affect the substrate temperature. These factors can reduce strength and cause critical fracture propagation, resulting in partial or complete surface failure. The main aim of this research is to analyze the surface pattern on the mild steel, which results from the engraving process. Specifically, the objectives are as follows. First, to analyze how a process parameter affects material removal. To determine the impact of laser engraving parameters on mild steel surface quality. And finally, to develop a design using a master oscillator power amplifier, or MOPA fiber laser on mild steel. The scope of this research is to create a design for a workpiece using laser engraving. The thickness of the workpiece plate, which use a different measurement such as speed and power of the machine running during the operation, is then used to evaluate the effect of laser engraving parameters on surface quality of the mild steel. Some of the scope of this research are to examine the structural and microstructural alterations on the mild steel plate. Next, the materials utilized in this experiment or testing are measured on a small scale and depth. And lastly, to modify a laser engraved machine's differences parameters. Chapter 2 Literature Review. Laser engraving machine has different types as each of the machine can be operated in each different materials, concept and situation. Some types of laser engraving machine are the direct diode laser engrave. Direct diode lasers are lasers in which the output of laser diode is used directly for a purpose such as laser material processing, such as laser cutting or laser welding. Using diode pump lasers, on the other hand, the diode laser radiation is used to pump another laser, whose output is then supplied to the application. Next is fiber laser engrave. Fiber laser engrave are perfect for marking black anneal metal and deep engraving. It have a wavelength of 190 nanometer, making them infrared lasers. Fiber lasers can mark a broad variety of materials. Although they are best used for metal marking, fiber laser engrave ideal for annealing and engraving because of their enormous power. But they cannot mark clear things because infrared light flows right through. They are based on the same long-distance communication technology that is used in long-distance communication. For CO2 laser engrave, it is a device that produces a laser beam from a gaseous mixture of CO2 that has been electrically treated. The CO2 laser beam has a wavelength of approximately 10.6 microns. This wavelength can be used to engrave non-metallic materials like as wood, plastic, fabric, paper, and glass. The CO2 laser is one of the most powerful and efficient lasers on the market, and it can be used for a variety of medical, surgical, industrial, and military purposes. The crystal laser engrave. Crystal laser produce intense beams because their beams have a great intensity. They are ideal for cutting hard and thick materials. The fundamental disadvantage of this laser is that it increases power causes frequent failures. Metal, polymer, and even ceramics are among the materials sliced by this laser equipment. Finally, the master oscillator power amplifier or MOPA laser. This type of laser can be defined as a laser system that includes a seed laser and a laser amplifier for increasing output power. MOPA can be made up of a solid-state bulk laser and a bulk amplifier, or it can be made up of a tunable external cavity diode laser and a semiconductor optical amplifier. They are frequently employed to make high contrast marks on other metals like titanium, nickel, alloys, and steels. There are four types of parameters used in laser engrave, which is power, speed, frequency, and loop count. Power is the most essential parameters in the material database. They can be specified as a percentage ranging from 0% to 100%. The laser's output power is described by the power laser parameter. Speed can be described as the laser head's movement. Speed also as essential as the power. Short exposure times result from faster speeds, while long exposure duration result from slower speed. Frequency is utilized to show the Q-switch frequency in laser pulses per second. Various marking effects are provided by changing the frequency. This parameter is used to directly modify the laser output frequency using the Q-switch. The loop count is the number of times the laser will pass over your target. The more loops there are, the more depth there is. Depth can be improved by raising the power of the laser, slowing down the marking speed, or lowering the frequency, or a combination of all three. However, this produces a lot of heat and might leave a black or uneven mark. Next is mild steel. Mild steel, commonly known as low carbon steel, is a form of carbon steel having a low carbon content. The quantity of carbon present in mild steel is typically 0.05% to 0.25% by weight, whereas heavier carbon steel are typically stated as having a carbon content of 0.3% to 2.0%, depending on the source. Mild steel also comparatively inexpensive when compared to other steel as the small amount of alloying elements in it. If not properly coated, the iron in mild steel is susceptible to oxidation or rust because mild steel lacks alloying components like those found in stainless steel. Some physical properties of mild steel are magnetic metal based on its ferrite content, exceptional tensile strength, high impact resistance, heat treatment to improve characteristics is not recommended, while durability and ductility are both good. For mild steel engraved, steel is the most used material, both as a raw material and as a component of industrial parts. Steel laser engraving does not require any pre or post treatment and does not require any contact with the part. The result is a durable, high contrast marking with a high definition finish that does not damage the steel. Steel laser engravers are versatile and offer a wide range of marking options, including engraving, etching, and annealing marking from the rawest to the most polished steel. It is the ideal high-speed technology for marking and surface engraving on steel. Chapter 3 Methodology. This chapter discusses the entire methodology clarification process for this project and in a mixed method theoretical study. The materials and qualities needed to complete this project are discussed in this chapter. This chapter discusses the machines that were employed during the experimentation phase to get the desired results in this study. Aside from that, the software utilized in the experiment was also covered in this section. The workpiece or specimen that will be used to analyze the entire laser engraving process will be the mild steel. Here are the mechanical properties for mild steel. Ultimate tensile strength with the value 400 until 500 megapascal. Density 700 and 7,850 kilogram per meter cube. The yield strength is 250 megapascal. The melting point is 1450 degrees Celsius. Young modulus of elasticity is 200 GPa. In the manufacturing laboratory at University Technical Malaysia Melaka, Faculty of Manufacturing Engineering, the Master Oscillator Power Amplifier MOPA fiber laser was used in this research. The Master Oscillator Power Amplifier, which generates a pulse frequency with a broader fiber, can be used to supply a power source for the laser. This enables MOPA laser to provide distinct engraving results in diverse polymers and metal materials when compared to other fiber engraved laser technology. Picture on the right is the software used in this research, which is the EasyCAD 2.76 software. This software is where all the setting of parameters will be conducted there before the engraving process can start operating. It was the chosen software on designing pattern on mild steel surface through the Master Oscillator Power Amplifier, as it can design the laser engraved region. The digital USB microscope is used to examine the grain size of the microstructure on the graved region and base metal. The sample microstructure was observed using a digital USB microscope. The etched zone and base metal micrograph of the workpiece were obtained using microscopy examination. Each engraved materials using laser engraving machine will be examined using the digital USB microscope to analyze the microstructure. From the engraved mild steel material, the look of the surface on the mild steel workpiece revealed which surface was preferable for product marking. The goal of the research is to provide the result of laser engraving selected metal with the best specification. Figure here shows the laser marked product with the best parameter using during the laser engraving process. That's all from me. If you have any question, do find me on my email or phone number shown here. Thank you for your attention as I appreciate it very much.